Hello, my name is Daniel Anij. Today you are welcome to chemistry lessons, and our main topic, the topic that we are going to study is electrolysis. By the end of the lesson, the student should be able to read the first law of electricity, which is the Faraday's law, to calculate the mass of a substance. Now, the first law of electricity, the Faraday's law, states that the mass of a substance liberated at the electrode is directly proportional to the quantity of electricity passing through the electrolyte. As we have discussed earlier on, we got to know that oxidation at the anode, oxidation takes place, and electrons are being transferred from the anode to the cathode, where reduction takes place, and at the cathode, ions over there accept the electron to be reduced to metal at the cathode when the electrical circuit is switched on. Now, according to the law, the mass of a substance liberated at the cathode, which is the electrode, is directly proportional to the quantity of electricity passing through the electrolyte. So mathematically, M is proportional to the quantity of electricity, which is the Q. But Q is equal to current times time, which is the IT. And then mass is directly, so if Q equal to current times time, then we shall say that mass is directly proportional to what? To the current times time, which is the quantity of electricity. Introducing a constant proportionality, which is the Z, we shall say that then mass is equal to Z times I times T, which is the electrochemical equivalent times current times what? Times time. Then the chemical equivalence is also giving us chemical equivalence, which is CE over Faraday's constant, which is F. And then chemical equivalent is also giving us what? Atomic weight of a substance, which is A, over the valency of that element, which is the V, or the molar mass of an element to 8 to the ratio of what? To the ratio of 8 to a number of electrons transfer in a balanced half reaction. Therefore, we shall conclude on electrochemical equivalent as Z equal to A over V all over what? F, which is finally giving us A over VF. Now, let's assume that the M equal to the electrochemical equivalent times current times time will give us equation 1. And this electrochemical equivalent over here 2 also giving us equation 2. Putting equation 2 into equation 1, we shall have mass being equal to atomic weight times current times time all of what? Valency times the Faraday's constant. So where M equal to mass of substance and the A equal to the atomic weight and the time, T equal to time in seconds, and the valency V equal to the valency of an element, and the F is the Faraday's constant. Let us calculate this. Let us solve this as an example to determine the mass of a substance. Now, this is the question. Calculate the mass of aluminium, the Al is the aluminium, produced in 1 hour by electrolysis of molten aluminum chloride. If the current is 10 ampere, and we have been given the atomic weight of the aluminium, which is 27, and then 1 Faraday is also giving us 96,500 coulombs. So, to solve it, we shall say that mass is equal to the atomic weight times current times time over valency times the Faraday's what? Constant. And then we need to put down the half equation or the half reaction. So to put down the half reaction, we shall have this giving us the aluminium metal. Aluminium equals accepting 3 electrons to give us aluminium metal. So from here, the mass shall be equal to the atomic weight, which is 27 times the current, which is 10 ampere, times the time. The time shall be 60. It is 160 times 5 times 60. all over the valency is 3, or the number of electrons. So 3 times the Faraday's constant, which is 96,500 coulombs. So in all, when we compute, the final answer shall be 3.36 grams. That is, that comes to the end of the lesson. Thank you very much. Next time we shall continue. Thank you.